So compound events in single-step experiments. When discussing probability, we often use a standard deck of 52 playing cards as an example. So that's why I got these for you today, so that you could see the 52 cards that are in a deck. It is important to understand what cards make up the standard deck. First of all, how many cards are in that deck? 52. There is 52. So if you are unfamiliar with cards, the first thing you'll notice is that each one of these rows here has 13 cards in it. 13 times 4 does make 52. Part B, so we're filling in this as we go. Part B, how many red cards are there? So we have one line of hearts, which is red, and another line of hearts, which is diamonds. Remember I said there was 13 in each one. 2 times 13 makes 26. If there are 26 red cards, there must also be 26 black cards because it's half-half. Part 3 says how many aces. Aces are the A that you see here, and there is 1 in each row, so that makes 4. 4 aces altogether. Now, when you play cards, you'll sometimes hear this word, suits. The suits in your pack of cards. They are the different symbols that are on the cards. The 4 suits are, this first one on the top here is called hearts. The next one, the second row, is diamonds. Yeah. The next one is spades. And the bottom one that you see here is clubs. And they are the 4 suits that we talk about in our pack of cards. Yes, it's a bit of a double up. It is a bit of a double up. So part D says, how many suits are there? There are 4 of them. It does say, and what are they? But I've already answered that in C. Okay, so I'm not going to write that again. So the suits are hearts, diamonds, spades, and clubs. They are the little pictures that you see that go along with the number or the letter. How many cards are there in each suit? So in each one of those lines there was 13. What are the court cards? Okay, another word we need to know. Do you know what that is, Poppy? Correct. So these picture cards here at the end are known as the court cards because the kings and the queens and the jacks are in their court, in the castle, the royal court. They're the court cards. Don't count the ace. The ace is usually considered as a 1 in most games. So it's only these 3 here. So there's 3 in each line. 3 times 4 is 12. We have 12 court cards in the whole deck. Oh, I wrote down the wrong one. What are the court cards? You're right. Read the question. It is the jack, the queen, and the king. There would be 12 of them, but it didn't ask me that. I just wanted to know what they were. Part G. There it is. How many court cards are there? 12. In how many ways can you choose a card that is red or a 7? So there's 2 different ways that you could calculate this. And remember that I do like you to show working out. So I'm going to draw a little line here. And I'm going to show you both ways that you could do this. So the probability of getting a 7 or a red. Okay, that's our proper notation on how we would write that. P for probability, we want 7 or red. First of all, let's just do one of them at a time. The probability of getting a 7. There's 1, 2, 3, 4 of them. There is 4 of them out of the 52 cards in our deck. Then I look at the red cards. How many red cards are there? 26 out of the 52. However, there is a small problem. Hands up. Can anyone know what the problem is? Yeah, Lucius, you're first. That's right. The 7s got counted, these 2 red 7s, they got counted both times. So if there isn't what we call an overlap where something is both a 7 and it's red, we subtract off the overlapping 2 cards, which is 2 out of the 52. Now, you can use your calculator for that if you wanted to, but because all the denominators are the same, you know you just have to go 4 plus 26 minus 2, which is 28 over 52. And then you simplify your fraction by dividing by 4. You can divide top and bottom by 4, which gives a 7 out of 13 chance of that happening. Now remember I said there was an alternate way that would also be acceptable. So here's my OR. Here's my second method, which is possibly a little bit shorter. So first of all, I'm going to do the probability of my reds, which was the 26 out of 52. But then I'm also going to add to that just the 2 extra cards that were 7s that were not red. Okay, so plus 2 out of 52, which does make 26 plus 2 is 28 out of 52, and then I'm back to the same answer from there. So slightly different ways of thinking about it, but I've shown my working out and I get the same answer either way. Okay, next page. Okay, not chatting. Okay, on the next page it says, 1 card is chosen randomly from a deck of cards. What is the probability that it is red? That's my first question. Yes, John. Oh, you're telling me the answer. Yes, okay, good. So remember to work out the probability. It's the number of favourable outcomes. We had that little formula. Number of favourable outcomes over the total. So there is 26 red cards. So that's my favourable cards. There's 26 of them out of the 52 that are red. And then you just simplify that. You can either simplify it by dividing in your head, or I'm happy for you to type things into your calculator. Of course, that is half the cards that are red, isn't it? So it simplifies to 1 over 2. Probability that it is not red. Remember the complements? If something has half a chance of being red, not red would be the rest to make it add to 1, which in this case is going to be half as well. Since I have 2 lines of working out there though, I'm going to do 1 minus the half, which gives me half as well.
Why are you minusing half? Because half is red.
Because I found that the probability of red was a half, not red means I want to subtract that probability from 1, which gives me a half as well. Just showing how I got it. You could have started completely from scratch and gone, okay, not red means it has to be black. So you could have also written 26 out of 52 again and got a half again that way. But I was trying to go over our complementary events that we've kind of touched on before. So either one of those methods is fine. Part C, what is the probability of getting a club? So the clubs are these ones down here that look a little bit like clover. There is 13 of them out of 52, and then you will simplify your fraction, which does become 1 out of 4 because a quarter of the clubs are these ones here. That whole row, they're called the clubs. Okay, so this bottom row is the clubs. They're the spades, diamonds, hearts. Yeah. One question at a time, Timor. Just like what I'm doing now. Yes, you have to do this. Yes. Okay, so question D. We want the probability of not a club. So let's do that by looking up here. Not a club means these 3 rows, the first 3 rows, 3 lots of 13 would be 39 out of the 52, which simplifies to be 3/4. And again, you could have done that by doing the complementary event. If there's a 1/4 chance of getting a club, that means there's a 3/4 chance of not getting a club. They must add to give 1.
So could you just done like 1
Yep.
minus?
Just like, yes, you could have, absolutely. Part E. I want the probability of a 7. So probability of 7, there is 4 7s out of 52 cards. I can divide top and bottom by 4, which gives a 1 out of 13. Remember that you can use your calculator to help you with the simplifying if you need to. Part F. Find the probability of neither a 7 nor an 8. So that's a fancy way of saying not a 7 or an 8. Because it says that word not or neither, it's the complement of the 7 and the 8. If I work that out first, so the probability of a 7 or an 8, what happens if I have a look here? I have 4 7s and I have 4 8s. So altogether, that is 8 cards out of 52. I'm not going to simplify that yet. What I'm going to do is I'm now going to come back to my original question, which says, I don't want the 7s or 8s. So how about I do 1 minus the part that I don't want? I don't want the 8 out of 52 that were 7s and 8s. Okay? That, to subtract those, you want to do 52 minus the 8 to find out how many extra cards there were there, which is 44 out of 52. And that simplifies to be 11 out of 13. Okay, another page here. G. Find the probability of a red ace. So just the red aces, there's 2 of them. We don't want the black ones. So there's 2 red aces out of 52 cards. Divide the top by 2, I get 1. Divide the bottom by 2, and I get 26. H. Find the probability of a red card or an ace. The probability of a red card, there is 26 of them out of the 52. It does say or an ace. So I've already counted those 2 aces because they were in my red cards, but I need to count these 2 black aces. So plus, no one should be talking, plus 2 out of 52. They already have the same denominator, so adding fractions, we do 26 plus 2 makes 28 out of 52, and that can be simplified even though there's not an extra line for it. I can divide top and bottom by 4. 28 divided by 4 is 7, 52 divided by 4 is 13. And I. We want a red card that is not an ace. So a red card that is not an ace, probably the easiest thing to do is to look at all your red cards. There's 26 of them, but we do not want the aces. So we take the 2 aces off, which means 24. There is 24 red cards that are not aces out of 52. I'm going to simplify by dividing by, what do you think? 4. Yeah. 24 divided by 4 is 6. 52 divided by 4 is 13. Okay, so there is quite a few questions there because there is just so many things that you can ask about a pack of cards. There is only 2 pages in your workbook, so get that out straight away. We're doing pages 11 and 12. So this stuff in here should all be finished. Here it is in here, page 11 and 12, starting now.